So we're going to identify the long-run behavior of these three rational functions and write it up in limit notation. And I'm going to do it all not using a calculator. You can, but I want you to see how to do it without one. What you do is you identify your lead term on top and bottom and realize this thing kind of acts like that for large x. So 4x over 2x. That reduces all the way down to 2, which means we have a horizontal asymptote at 2 for a rational function. That means both ends are going to go to 2, which means the limit as x approaches infinity of f of x equals 2, because as x gets really large positive values, the outputs will get closer and closer to 2. And the other end is when we go to negative infinity of f of x, that is also going to be 2. So with rational functions, when you have a horizontal asymptote, the end behavior is going to be the same in both directions. So then it's just a matter of getting this limit notation down. Once again, we identify the lead term in top and the bottom. This pretty much acts like x over x squared, which reduces down to 1 over x. As x goes to infinity, this thing is going to go to 0. So I'm going to use an arrow instead of equals because it's not equal to 0. And so that, again, that's a horizontal asymptote. So just like in A, we have the limit as x goes to infinity means both our ends, oops, not f of x this time, g of x equals 0. And then we've got the other end, limit as x goes to negative infinity of g of x equals 0. So when we have that horizontal asymptote, both ends go to the same place. Okay, let's circle our lead terms. This thing, when x is large, is going to act like negative x to the 5th over x to the 4th. Simplifies down to negative x. All right, if we were to graph that, it's a linear function that looks like this. We can see that as we go to the right, the y values go to negative infinity. As we go to the left, y values go to positive infinity. It's a polynomial with an odd degree. They're in opposite directions. Negative coefficient, so it's opposites. So to write this up in limit notation, limit as x goes to positive infinity of h of x equals, as we go to the right, it goes down, equals negative infinity. And then limit as x goes to negative infinity, so as we go to the left, it goes up, of h of x equals positive infinity, and there's our end behavior.